Hi and welcome back to the Intelligent Auto channel. This is part 2 of the video for the CAN problem with this Jaguar 2.2 X-Type. If you remember from the last video, it was a no crank, no start. At the end of the last video, I left a question. Do you think it's the engine control module that's at fault, or do you think it's something else? So today, what we're going to do is some further testing to actually establish the true cause of this CAN problem with this vehicle. If you remember last time, what I did was I unplugged the multi-plug over on this strut top of the engine bay, and what that proved was that when that multi-plug was unplugged, so it isolated the CAN network from this way to the over here, the CAN signal came back to life. I then went on, I've pulled the PCM out now. I then went on to unplug the PCM here, and again that had the same effect. It cleaned up the CAN signal. So that was where the question mark lay. Was the problem with the PCM, or was the problem with the wiring? I studied the network a bit closer from that point and soon realized that the wiring diagram I had was not completely accurate for this vehicle. So let's take a look at how this network is actually laid out. So this wiring comes from over here, this block connector. It drops down underneath the battery. It goes down underneath the radiators and along the front of the vehicle. It then comes back up the front of the engine through this harness here, and that's the CAN wires there. And it comes down here, and as you saw in the other video, the harness went under this block connector here and towards the PCM, which at the time was still in its hole at the back here, and it appeared to connect straight to the PCM. I've since found out that that's not right. What happens is the wiring comes through this harness, it drops down, but what it does is it turns back on itself here, and it comes back to this block connector. So as you can see on the laptop screen here, the signal in the CAN is still pretty scruffy. Now if I take this block connector here, now bearing in mind this harness here runs underneath this block connector and would appear not to actually come anywhere close to this or come through this block connector. But if I unplug that, like so, you can see the signal cleans up again. I'm going to get you a bit closer and I'll show you why. So here we are. This harness, this side of this harness here, the wiring, when I trace it back, goes underneath the power steering reservoir here, that way, underneath the fuel pipes. It comes up here and it comes straight onto the engine. It's this harness here and this harness here. This harness here, now remember on the diagram we had a turbocharger which was CAN controlled, which is this component here. So the wiring comes along here. So at that point there I thought, is it the turbocharger which is mucking the network up? Obviously when I unplug the PCM, the turbocharger loses its power supply. So what I did was plug this back together, get it the right way. CAN signal's gone scruffy again. I'm going to pull you back so you can see the screen of the PC and what I'm doing at the same time. So I've got this connector plugged back in, and see the wiring, the CAN wires to the turbocharger come through this harness here along the top of the engine, and they go to the turbocharger. So if I unplug the turbocharger, which is easier said than done, there we go, that's unplugged. it has no effect at all on the CAN signal. So I know it's not the turbocharger. So again, leaves the question, is it the PCM which is at fault? So this CAN wire comes through this harness, it drops down here, it comes into this harness here. This is the main harness that it came through. What I didn't realise, because the diagram that I was provided with was incorrect, was the CAN wires where they come up this harness, which are these ones here, actually don't go straight to the PCM, they go into the back of this multi-plug here. Now as you can see, we've got two lots of CAN wires. So we're looking at the back of the multi-plug, they actually change colour, which it did show on the diagram that they did change colour towards the turbocharger. So we've got two lots of CAN wires coming through here. So me unplugging the engine control unit was cleaning up the CAN signal. But what it was also doing as well was taking any load off the CAN network throughout the whole engine bay. So these wires, come back to these two wires, they come up this harness and they double back, they come through this multi-plug here. And we've got two sets of CAN there, and they come out of this side of the multi-plug, they turn to, I think it's blue and grey and red and grey. So the two lots of CAN wires come down this harness, they come under the power steering here, and they come into here, come up the side of the engine into here, and they go along here. At this point I'm thinking, well, two components on the engine control that are CAN controlled. I just couldn't, rack of my brains, couldn't think what it would be. I knew the turbocharger was CAN controlled, but that was it. So I stripped this off, I've retaped it now, but I stripped this harness back to try and trace where these wires were going. They were coming along here, and what they actually do is they're actually spliced together here. So the engineer that designed this one was, I think he must have been on a day, well, I don't know, I think he always just wanted to pay a mechanic off at some point, and yes, I'm it. So basically the wiring comes through the engine bay, comes up here, comes close to the engine ECU, but not quite close enough, and doubles back inside the harness. Comes two lots of CAN wires, come through here, and they come here, and they're spliced together. So basically I've got CAN going that way, and I've now got CAN coming back this way, so they come back onto the onto this multi-plug with these ones here. They're wrapped around this little steel ring here. Basically that's just a suppressor to try and absorb any interference. And then at that point there, that's where they go into the engine ECU here. So it was a bit confusing. So needless to say, when I unplug this here, even though I'd never assumed that I was actually killing the CAN to the engine control unit, the CAN signal was clean enough. So at this point here, I'm still thinking, I've got a bad engine control unit. I'll keep going back to this engine control unit. So I'm left with at a point now where I'm thinking, do I just go for a PCM, and is that going to cure the fault? It's a big shout. I priced a new PCM, it's £800 and odd plus the VAT. Plus the time I spent on the car, you know, it could potentially sort of write the car off. So yeah, at this point here, I'm, should we say, a little confused. I'm going to admit here, I mean, CAN, yes, I understand it, but I'm not going to say I'm any sort of actual guru with it. It's like everything with cars, every day is a school day, it's a learning curve. So what I did was, there's a YouTube channel I follow called Definitive Diagnosis. It's run by a guy called Glenn Norris. He's based in the UK. And basically his passion is CAN. it's his hobby basically, and he's been building CAN simulators. He's been building CAN networks on the bench and studying CAN networks. But again, it's a self-taught skill from him. It's been trial and error. So what I did was I reached out to Glenn. I sent him a message and asked him if I could run this vehicle past him, send him some screenshots of the CAN signals, and if he had time, could he cast his eye over them, which he kindly responded very, very quickly and kindly said, yeah, no problem. So I sent him a couple of screen captures off the PC of the CAN network, and this is the point where you have that light bulb moment. Few messages backwards and forwards, and basically this is where I realised I had been chasing my tail down a rabbit hole. The one thing I didn't do, which I should have done in the first instance, was check what's called the physical layer of the CAN network. Now, every CAN network has two resistors in it. They're called termination resistors, and they live in two separate modules. On this network, one lives in the PCM and one lives in the ICM, which is the instrument cluster module. The reason we have termination resistors is, what they do is they absorb the CAN signal to stop what's called reflection back down the CAN wires. So the signal's coming into this module and it has been absorbed into this module, so it can't bounce back out this module and bounce back down the CAN wires and give a rogue signal to another module on the network. As I say, there's two resistors. There's one in this network, it's in the PCM, and the other one is in the instrument cluster. There are 120 ohm resistors, so when you put them together you get 60 ohms of resistance in the physical layer. So again, this is one, I'm not perfect. I've never professed to be. It's a mistake I made. I should have checked the physical layer of this network. So that's what I'm going to do now. To do this, we need to switch the ignition off. We need to take the keys out of the car. We need to allow the car to go to sleep. So that's what I'm going to do. So we're using a multimeter. Just check that, the plausibility. Oh, that's not good. Check that again. Got a bad probe. I'll change the probes. There we go, 0 ohms. To check the physical layer, we can access the CAN network at any point. This can be done sometimes through the diagnostic socket. I'm not going to do it through the diagnostic socket in this car, even though this car, I could do it through the diagnostic socket. Reason being is, good practice, don't do it through the diagnostic socket, because some vehicles only have what's called diagnostic CAN going to the diagnostic socket. They haven't got a direct connection to the actual network. So I might as well just go somewhere easy. So what I'll do is I'll just back probe it here and here and take a resistance check. And as you can see there, I've got 115 ohms of resistance. Now again, two termination resistors, one inside the PCM, one inside the instrument cluster, both at 120 ohms. Add them together, put them together, we should have 60 ohms of resistance. I've got somewhere close to 120. So what that tells me straight away is that I've either got a problem with the termination resistor, or I've actually got a problem with the wiring between the two termination resistors. So I could have a break in the circuit somewhere. So to identify that, the next thing I do is I'm going to take a resistance check at the PCM, and I'm going to unplug probably, I'm going to unplug this connector here, which will then disconnect the PCM from the rest of the network. So there's my two CAN wires there. What I'm going to do is I'm going to put a link to Glenn's channel in the description below, so you can all go over and have a look. Very clever guy. Really knows his stuff with CAN. It's his passion. So keep an eye on the resistance. I'm going to unplug this, which will disconnect the network from here that way back towards the interior of the car. So straight away, you can see I've got 120 ohms of resistance within the PCM, because the PCM is now disconnected off the network. So that tells me that the termination resistor within the PCM is intact. So the next point, what we need to do is we need to take a resistance measurement from here that way towards the instrument cluster to check the resistance in that side of the circuit. It's going to be on this wire here, because that's the wiring that comes from the main part of the loom. This is the wiring this is this wire here that's coming up here. So I'm going to get a couple of breakout leads and put them into that plug. So yeah, that one there. So here in the third row, 1, 2, 3, and the first two wires. 1, 2, 3, so there and there. And then take find the end of my multimeter leads there. We'll put them in there, them in there. As you can see, we have an open circuit. So we have an open circuit from here, that way, through that plug over there, inside the car, through the transmission module, through the air conditioning, and ultimately end up at the instrument cluster where the other termination resistor is. So I need to know where this break is in the circuit. So again, by speaking to Glenn, this is where, see, I had this light bulb moment. Sort of, I already knew the answer, but I just overlooked it, should we say. Need to chop the circuit into sections to try and identify in which section of the circuit the fault lies. So next, what I'm going to do is I'm going to take you over to that multi-plug there, and we'll take resistance checks in the other direction. So unplug that from there, and I'll move you over to the other side of the car. Before I do that, what I'm going to do is, because I'm going to break the circuit there, I'm going to link these two CAN wires together. So testing this way, if the wiring's good on this side, we basically should have no resistance in the circuit, but we shouldn't have an open circuit. Okay, so here we are. So I'm going to unplug this. So this side of the plug, the wiring is going back this way, and it's going into the car. So again, take another couple of breakout leads. I've already identified that there's the yellow CAN wire there, there's the green CAN wire here. So we'll just identify the pins. So third row, that one there, very last one. That one there, third row from that side, very last one. Grab the end of the multimeter leads, plug them in, and we'll take a measurements of resistance. And as you can see, very close to 120 ohms. So what that's telling me now is that the termination resistor inside of the instrument cluster is good, and the wiring between this point here and the instrument cluster is also good. So the fault must lie in this direction. So using the corresponding pins on this plug, there's my yellow, which is the can high, I believe, third pin, and there's the green here, which is there. I'm now going to take a measurement of resistance through this side of the circuit. Now bearing in mind I've got it looped at that side where I brought the two pins together. Now I've got 41 kilo ohms of resistance there. Tracing the wire down, as I say, it goes under the battery, goes underneath the battery tray, and it heads down over. Now between this point here and that point over there, there's another component within the network, which is the transmission range switch. So I'm now going to unplug, I'll have to come on that side, I'm going to unplug the transmission range switch to see what effect that has on the physical layer. As soon as I unplug that, it's gone open circuit. Now I'm going to take you back to the diagram and we're going to have a look at the layout. As I mentioned before, the diagram I was provided with through my subscribed data system is actually incorrect. It's not accurate. I wouldn't say it's incorrect, it's not accurate. So what I've done is I've actually drawn out the network on the whiteboard accurately the way that the network is actually configured on this vehicle. So here's the original diagram here. It shows that the CAN network comes through the transmission range switch, which it doesn't. We've proved that. It does go through the air con. It does go through the transmission control module. The transmission control module is actually here, and the transmission range switch is here. The ABS, it says that it comes in here. It doesn't. It comes in before the transmission controls, the transmission range switch. So if we were to sort of have a look, put some connectors in, we would have a connector there, which is the inner wing connector on the right hand side of the car, and the ABS would be connected in here. And then we would have another connector sort of somewhere here. And what it doesn't show is it doesn't show those spliced wires going to the turbocharger. So you can see where my confusion lay. So this is the actual layout of the network. We've got instrument cluster at the top here, comes through transmission control module, comes through air conditioning. The ABS is branched off at that point, so this is where it comes into the engine bay, and the ABS wiring runs along the bulkhead, around the right hand side of the car, down to the ABS control module, which was behind the right hand headlamps. There's the block connector here, so the ABS is connected before the block connector on the left hand wing, and then after that block connector the range switch is teed off here, which is on top of the gearbox, and it comes to the right hand block connector, and it comes out of the right hand block connector towards the turbo, goes to the turbo, but it's spliced back over, and it comes back on the same side of the block connector and back out the opposite side of the block connector to the powertrain control module. So hence why when I was unplugging it here, which is the block connector on the driver's side, right hand side in a wing, it was cleaning up my CAN signal, because what I was doing was I was actually disconnecting the PCM where that resistor, the termination resistor, lives off the network, so there was no load on this side of the network. So as you can see, termination resistor here, termination resistor there. They are both 120 ohms. Add them together and you get a 60 ohm total resistance within the circuit. So when I disconnect here and measure the resistance here and here, I'm measuring the resistance of the one single resistor inside the powertrain control module, which I was measuring at 120 ohms. And when I disconnected here, the best way, disconnected there, and I was measuring that way, I was measuring the 120 ohms in that side. So basically the termination resistor on the instrument cluster. Then I then took my measurements here and here, and I got the 40 kilo ohms, I think, if I remember rightly. But I've still got the range switch in the network. So I disconnected the range switch there, and that's where I got my open circuit. So basically, where the resistance check here and here, I've got no resistance. I've got, sorry, I'm not going to say not no resistance. I've got an open circuit within the network here. So what that means is I have got a break between this point here and this point here, going that way between that plug. So that, when you look at the layout on the vehicle, is the harness that runs along underneath the radiator, underneath the battery tray. Now, sorry, I'll correct myself, it's not underneath the battery tray because the range switch is actually after where the harness runs through the battery tray. So when I unplug the range switch, I still had an open circuit. So we've got a break somewhere between these two multi-plugs. So I'm going to elevate the car so I can get access to the wiring harness. And I'm going to do some tests. I'll show you how I'm going to test the circuit. So to test this wiring, I've got this disconnected. I'm going to take, that's my two wires there. That one there. And that one there. I'm already connected at that side on that multi-plug. I've broke in. And I'm going to take continuity tests from this multi-plug to that multi-plug to determine which one of these two wires has the fault. So I'm going to start with the yellow, which is the can high, I believe. Put that multimeter in view. Into there. So picking the yellow wire on this side, which is the very bottom one. I take a resistance check. As you can see, I've got no resistance, and if I put the beeper on, it's telling me I've got continuity. So that wire's good. So I'm going to swap onto the green, which is the can low. And put on the corresponding pin on this side. As you can see, I've got an open circuit. So the problem lies between these two multi-plugs. I've got an open on the can low. So I'm now going to take tests down the green wire, the can low, at accessible points within the harness to try and determine which section of the harness the open exists in. I'm going to use this thing here. It's called a Phil's probe. Anybody called Phil you've got a probe named after you. Basically what it is, it's a side probe. It's got some very, very small needles on the end of it there. There's multiple needles, I think there's about 5, which if what we do is, so I'm going to start here, put it on there, just release it. The spring is enough to push through the insulation, leaves the tiniest of pinholes in the insulation, and we'll take a resistance check. So I know that we've now got continuity from this point to that point, so I know the brake doesn't lie in this area. So I now need to access the wiring further along the network. What I'm going to do is I'm going to elevate the car and go under the radiator where the wiring harness runs under the radiator and do the same tests. You'll not be able to see the multimeter, but because I've got the buzzer on, you'll hear the audible beep. I'm just going to lie the multimeter on the bumper of the car while I'm under the car. So let's take it up. So this is the wiring harness here, running along the front cross member. So what we'll do is, put that over there for now. I'll drop it down at points and open it up. So if we peel that trunk and back, I can see the van wires there. There's the can here. There's the can wires there. So again, green wire we're concerned. So we take the Phil's probe and we probe the wire there. If you can hear that, buzzing. So we know that we've got continuity from that plug up on the driver's side wing to this point here. So take that out of there. We'll go further along the harness, pull it down here, get a blade. Found the wire here. And put it in there. And there's no beep. So we know, oh, look at that. There we go. There's our brake. Wasn't that far away from it. There's our broken wire. So I'll just take a check there. You can hear the beep. There's our broken wire. So that's been the problem there. Now to prove this, what I'm going to do is join those two wires together and hopefully this car will start. Tiniest green crusty on there, but the copper is actually good. So obviously it's been a fresh break, or it's just snapped. But the copper's not oxidized at all. So right, we'll put a join in there. What I'm going to do is use one of these. It's a crimped, heat shrunk join. So twist, because we don't need to chop any wire out. Stick that on there. It's good. maybe start a discussion about this, because there's two trains of thought with connecting wires. I know the main dealers always say you should use a mechanical connection like this and shrink it, whereas a lot of people use a soldered connection. There's two different schools of thought with this. Some people say the solder joint is better, but then there's other people say that the solder joint can then become brittle and break, where the mechanical connector, once if it's connected good, it should be good for a good long period. Get down in the comments box and put your views on that. See, I'm going to use that here because I don't have to cut any wire back. The wire is still good. If I was cutting wire back, sort of back up to here and back to there, I would possibly solder a new piece of wire in. But because I don't actually have to cut back, but I don't want to stretch the wire to solder it, I'm going to use this mechanical link. So I'm just going to shrink it now. With this. That's a trunk, and for good measure I'm going to put some liquid tape on it, just in case there's any chance of any water ingress getting into it. Basically this liquid tape is like a rubberized paint, and it weatherproofs the joints. So what I'm going to do now is connect the harnesses back up on the multi-plugs either side of the engine bay. What I'll do first is take a measurement of resistance, just make sure that the PCM terminating resistor is actually visible at this side. And that will verify the wiring fix. There we go, 120. It's actually gone into kilo ohms range for some reason. We'll just, it's it there, it's because I've got the beep on. Take the beep off. Do it again. There we go, 120 ohms. So confirming that the fix in the wiring was actually being the cause of the problem. The break in the wiring, should I say, has been the cause of the problem. So I'm now taking a resistance check through that wiring right back to the PCM, and I've got my 120 ohms resistance. So the physical layer is back intact. So when I plug this in, this car should start. Here goes the moment of truth. Nope. Let's go. I haven't plugged the range switch back into the gearbox. Plug that back in. Schoolboy errors. Try again. So So I'm going to call that a fix. So as you can see, our CAN signal now is back to where it should be. There's no interference on it. So again, proving that the break in the wire has been the problem. So I'm just going to wrap this one up now. What this video has taught me is basically do the physical layer check first on the CAN network. An error on my part. I'm not going to sort of edit it out of the video. If I'd done that check in the first place, I wouldn't have been sent down that rabbit hole thinking that the PCM was faulty. Luckily, I realised before I actually went and bought a PCM for this vehicle. Once I sort of stripped the wiring back, and I realised that that CAN network doubled back on itself. So, as I say, if I had done the physical layer check in the first place, I would have initially found that one of the terminating resistors was missing off the circuit, which would have then sent me in a slightly different direction, should we say. Again, I'd like to give thanks to Glenn for his guidance on this one. I've put a link to his channel on the bottom, on the description of this video. Go over there, watch his videos. He is literally a CAN guru. And subscribe to his channel. Hit the bell for notifications. Also as well, can ask you to subscribe to my channel. Hit the bell for notifications and get down there in the comments. Leave your comments, leave your feedback, good, bad or indifferent. I'm not really bothered. All feedback is good feedback. From my point of view, it's a learning curve. Every day in this job is a school day, and anybody says that it isn't, I would say is a bloody liar. But yeah, get down in the comments, leave your views, and hope to see you in the next video. Thanks for watching.